This law of logs is one of the hardest to wrap your brain around when you're first trying to learn logs. So I hope this example will help you to iron out some of those difficulties. Let's start by finding the inverse of the function f of x equals b to the x, where b here is just some fixed base. We'll start by writing y equals b to the x, and then as we always do when we find inverses, we'll switch x with y, so x is equal to b to the y. And then we're trying to solve for y, so we release it from the exponent by taking the log base b of both sides. So the log base b of x is equal to the log base b of b to the y. Now remember that the right side is just asking the question, b raised to what power gives us b to the y? And the answer is obvious, it's y. So our end result is y is equal to the log base b of x, and that is the inverse of f of x. So we'll write that as f to the negative 1, which means f inverse of f of x is log base b of x. So here are our function and its inverse. Now let's just pause here for a minute to prove that when we put the function f of x into the inverse function, we just get x back. So f inverse of f of x is the log base b of b to the x, which we've already shown is just x. What's a little more difficult to wrap your brain around is that f of f inverse of x, which is b to the power of log base b of x, is also equal to x. And that just has to be for inverse functions. All right, now let's look at that law of logs in blue above, and let's try to prove it using what we know so far. So we'll just rewrite this. Log base b of x to the a is equal to a to the log base a of x. Now it's this thing on the left side that's kind of tricky. We know what the expression means. It means b raised to what power gives us x to the a. That's the thing that's difficult to wrap our heads around. But we'll approach it just like we have any other problem like this, raising both sides as a power of the base. B to the log base b of x of a is equal to b to the a log base b of x. Now we've already shown down here that the left side is just got to be equal to x to the a power. Now we can use the laws of logs, namely raising a power to show that we can rewrite the right side like that. But there's nothing that says we can't swap the two parts of that exponent. So we can put b to the log base b of x in parentheses and raise that to the a power. Now what's in parentheses is just x, and that's raised to the a power. So we have x to the a is equal to x to the a, and we proved our identity.